This is Dummyhole, a medium challenge from SECCON Qualifications 2025, involving various vulnerabilities, and here is the solution. The challenge hosts a simple web page with register and login functionality, and after we register and login, we can create a blog post. Okay, here we have the title, the description, let's upload it. Let's send it to repeater with Ctrl R, the image and the upload. Yeah, let's send the requests. And here we delete the PNG content and write our own JSON. And the important thing is to start the image URL with dot, because that's the subdomain, the web. And add the content type plus JSON. Now when we send it, we correctly created a new post. Let's see what the image under this post look like. It should be this JSON, not this PNG raw bytes under this ID. And as you can see, we have the JSON with the custom image URL and the content type is plus JSON. Let's now submit the path traversal path to the admin bot, and let's wait a bit. It should be right in 3, 2, 1. And yeah, we got the flag, as you can see here. It's decoded, so we can see it nicely here. So that was the exploit in action. Now let's look at the source code to see why it actually works. Let's start with the upload endpoint, as that is the first injection point that we have. So going to the source code, as we can see, we are able to submit image PNG plus JSON because the check is improper here. After that check, it issues a put object command to the RESTfs service and sets the object content type to the given MIME type, so our plus JSON. Now we are looking at the API report endpoint. As you can see, the only validation that is happening here is whether the ID is a string or not. It's not actually checked for being a valid UUID. So when we see the visit function, here we also can see that the ID is not validated at all, just put in the encode URI component, which doesn't necessarily stop us from anything, and we can just supply here the path traversal. And why does this path traversal work? Let's see the actual page of loading the post. Here we have the endpoint that handles the post request. As you can see, there's nothing connected to the ID logic yet. When we visit the post HTML that is rendered by the get endpoint, you can see that here we get the post ID, then there's an import call, but remember, in this place, the post ID is actually our path traversal, so it becomes basically images and our UUID. And because of this with type JSON, we need to have the content type returned to be proper JSON format. So basically our post data can be treated as the image because we have the valid content type JSON. Later, it simply assigns the title, the description, and the most important part is this image URL. You might be wondering why it had to start with a dot and not just our URL. Because of this location origin. When we inspect it in the browser, what bot sees, we can actually go in here and see. The bot actually sees the HTTP web. This is the Docker internal address that bot visits. So we need to have a suffix that just goes right to our exploit domain. Later, it is assigned to the image frame src, which becomes this iframe source. Note that this iframe is credentialless, so it is not showing any cookies, and that's why you need a CSRF vulnerability. Let's see if there's anything on the server that allows us to do it. After a little bit of digging, we can see that the logout endpoint has actually some CSRF vulnerability we can exploit here. So if our webhook site submits this logout with post ID and fallback URL, we can see it renders the logout page with replace those values to our set values. How we can exploit it? We need to check the logout HTML file. As you can see, here we have a set timeout to 5000. This means that this piece of code will execute after 5 seconds. But what happens before it? A redirection happens because the location.cref is assigned with some path. So our job here is to stop this redirection so that after 5 seconds it goes to our fallback URL that we specify. And this assignment here is especially malicious because there's a JavaScript protocol that allows us to execute JavaScript instead of redirecting. So how do we actually stop the redirection? Well, there are a couple of methods. However, I think that using 2 special characters is the easiest one. When we see at the payload HTML, you can see this form that is the CSRF vulnerability. As you can see, we are posting to the action web/logout. For bot, that will be a valid domain. And for the post ID, we are submitting this HTML encoded entity and this one. This basically is a tabulator, and this one is less than tag. It is encoded like that because it is a valid HTML tag. And these two things, if they are at the end of the URL, they stop the redirection. The second URL will be the malicious one that actually sends the cookie. So we are setting it to JavaScript location, and then we can use the JavaScript we want. In this case, we want to transmit ourselves the document.cookie. In the script, we just submit this whole form from the point of view of the bot from our iframe. There's a really neat explanation on the critical thinking blog post about how does this stop redirection. I really recommend reading this because it's a really valuable knowledge. I link this post in the comment down below. Let's now go to the webhook. As you can see, it's a very simple Python server that just serves the payload HTML and prints ourselves the path that request came from. One thing that is really important to understand this challenge well is how does it help us that we submit an image with our JSON. It is because by default the page uses the API post with the ID and it responds with the title, descriptions and the iframe source, which is this image URL. When we see the image endpoint, we can see that it streams the body of a file that is in the Rust.fs service. So practically our malicious JSON with our set image URL. That's it. Simple logic bugs changed together.